So, if you've ever worked with AWS Lambda, you know it's got this mix of, well, magic and a bit of mystery, especially when a function fails. It can feel like you're just staring at a black box. Well, today, we're going to crack that thing open. We're turning that black box into a glass box, giving you all the tools you need to see exactly what's going on inside.
I mean, does this feel familiar? You push out a new deployment, something breaks, and all you've got is a vague failure message. You're left wondering what in the world is happening inside that execution environment. It's a feeling I think pretty much every serverless developer has had at some point.
You know there's a problem, right? But trying to sift through mountains of data to find that one tiny root cause, it can be a really daunting task. The very thing that makes serverless so powerful, this distributed, on-demand design, is also what can make it so hard to see into. But it absolutely doesn't have to be that way. By the end of this explainer, you're going to have a super clear framework for observing your Lambda functions. We'll walk through a core toolkit of AWS services that lets you see exactly what's happening, no more guessing. Okay, so let's start with the big picture, the 30,000-foot view. Because before we can fix a problem, we first have to know that a problem even exists. This part is all about answering that first, most basic question. What is the overall health of my function right now? And our first tool for this is CloudWatch metrics. Now, here's the best part. You are already using them. Lambda sends these out automatically for every single one of your functions. There are no code changes, no extra setup. It's just on by default. Think of these metrics as your first line of defense. They're like the vital signs for your application. Now, there are a bunch of metrics, but honestly, these are the 4 you absolutely have to watch. Invocations tells you, hey, am I even running? Errors tells you, uh-oh, am I failing? Duration is all about, am I running slow? And throttles, well, that's your function screaming, help, I'm getting too many requests and I can't keep up. Together, these 4 give you a complete health check with just a quick glance. And this is where you can see how powerful this is. A simple graph like this can alert you to a problem in seconds. Let's say you see a massive spike in errors right after a new deployment. Boom, you immediately know what happened and roughly when it all started. It is quite literally the smoke alarm for your application. All right, so the smoke alarm went off, a metric told you what went wrong, a big spike in errors. Now it's time to put on our detective hat and figure out why it happened. And for that, we need to turn to our logs. So, if metrics are the smoke alarm, then logs are the forensic evidence. They give you the detailed, ground truth story of what happened in one specific invocation. We're talking the stack trace, the exact error message, any variables you decided to print out. It is all right there. Now, this illustrates a super important best practice. Look, plain text logs are fine for a quick peek, but they just don't scale when you're dealing with thousands or millions of invocations. By logging in a structured format like JSON, you basically turn your logs from this messy wall of text into a queryable database. And trust me, that is a complete game changer for debugging. And here's why it matters so much. With those structured logs, you can use a powerful tool called CloudWatch Logs Insights to run queries that look a lot like SQL. With just a simple query like this one, you can instantly sift through millions of log entries to find every single invocation that threw an error. This is how you find that needle in the haystack, and you find it in seconds. Okay, so we know what went wrong and why, but what if the problem isn't an error at all? What if it's just slow? Where is my function spending all of its time? This is where AWS X-Ray enters the picture. Think of it like a GPS for your requests. It's a distributed tracing service that follows a single invocation as it travels through your Lambda function and any other AWS services it happens to call, mapping out that entire journey from start to finish. So for Lambda, an X-Ray trace breaks the execution down into 2 key parts. The first one, AWS/Lambda, shows you all the service overhead, like the time it takes to spin up a brand new environment for a cold start. The second part, AWS/Lambda/function, that's the time your actual code was running. This immediately tells you if the slowness is coming from the AWS platform itself or from something in your own logic. And by connecting all these individual traces, X-Ray builds out this amazing service map. It's this powerful visualization that shows you exactly how all your different microservices are connected. You can see the request flow all the way from API gateway to your Lambda function and then out to a DynamoDB table, all in one clear diagram. And this, right here, is X-Ray's superpower.
If your function is running slow because it's stuck waiting 800 milliseconds for a response from some other API, X-Ray will show that clear as day on the trace timeline. It pinpoints the exact source of latency, which turns a really frustrating performance issue into a clear, actionable problem you can go fix.
So there we have it, our core toolkit: metrics, logs, and traces. But sometimes you need to dig even deeper. For those times, there are a few specialized tools you can add to your arsenal. This table breaks them down pretty nicely. If you need deep system-level metrics, like how much CPU or memory is being used inside the execution environment, you'd reach for Lambda insights. For a more traditional holistic application performance monitoring view, application signals can auto-instrument your functions for you. And to answer the critical question of who changed my function's configuration last Tuesday, CloudTrail gives you a complete audit log of every API call. Okay, let's bring it all together. We started with a black box, right? A function that was just hard to understand. But by combining these different tools, we've totally transformed it into a transparent system. And this is the key framework to remember. Metrics tell you what is happening at a high level. Logs tell you why a specific invocation failed. And traces tell you where your application is slow. See how that works? Each tool answers a different but equally critical question. So when you systematically apply this toolkit, you completely remove the guesswork. You're no longer just staring at that black box, crossing your fingers and hoping for the best. You've actually built yourself a glass box where every single action, every error, and every delay is visible and, more importantly, understandable. And it all comes down to these three pillars of modern observability: metrics, logs, and traces. Mastering these is really the foundation for building robust, reliable, and truly debuggable serverless applications. So I guess the only question left is, where are you going to start? Are you going to go implement structured logging to make debugging faster? Or maybe finally enable X-Ray to hunt down that performance bottleneck you've been chasing? The power to turn your black box into a glass box is now officially in your hands.